Yeah, today's session we are going to work with the language C sharp. We are going to learn now the syntax of the language C sharp. See, basically the whole agenda goes like this. It's a long topic, so I've broken the whole thing into 3 sessions. I'm going to divide it. In the first session, we are going to cover why do we use data types, why do we have, what is global memory, stack memory, heap memory, what is common type system, what is reference type and value type, what are data types and variables and how to declare them, initialize them, casting, implicit casting, explicit casting. Then we have some feature called as checked unchecked code blocks to do overflow checks. This is what we are going to cover in our first session today. And then in the other 2 sessions I'm going to cover the rest of the features related to the language basics. The whole agenda, I would say, is upon concentrating in and out about the language features. We are going to concentrate here about various aspects of C# language. I would say any language you learn, whether it is VB.NET, C# nowadays, or if it is Java, or if it is C, C++, Pascal, any language, the first thing which a developer or programmer has to learn about the language is the syntax of the language. So let us be very clear that today's agenda, today's session, we are concentrating purely on the syntax of the language, the rules of the language. See, unlike human language, these languages are a little more strict. So more you know about these languages, more efficient you would be at the time of writing code. The more rules you can remember, the more efficient you are. See, most of the times what happens is developers, they just have an overview of the language and then they start programming immediately. Of course, there is language compiler which keeps telling them this is what they have done wrong, this is what they have done right. But what my understanding is, if you are aware about all the language features well in advance, before you start taking up any kind of coding or any kind of project or application, your approach would be totally different. If I start learning English and at the same time I have to teach .NET to you people, I don't think I would be that productive. So if I first learn proper English, then I start teaching you .NET, the productivity is going to be different. So same way here, learning the language at this point of time is very important. And once we learn the language, all the features of the language in and out, then writing programs, writing applications using these language features would really make a huge difference in your programming of application approach. So let us begin with the first topic of today, that is why data types. Why do we use data types? Yes. So before that, every language you take, this would be the first topic. See, I can say we have categorized data types as integral type, floating type, and other data types. But before that, according to me, the reason why we make use of data types in every language is only then, based on the type of data type, based on the size of the data type, the compiler is going to set the size of variable, and accordingly that many number of bytes the variable will be allocated memory at runtime. Let us take this way. Any application, I say, is made up of 2 things: instructions and data. We cannot think of application without instructions. At the same time, we cannot think of applications without data. It's a combination of instructions and data. So it is the data which is going to flow through these instructions as per our requirement. So as a programmer, you are supposed to write a program for the data processing. How you process the data, how you take the input, how you generate the output, all that is going to vary based on your requirement. So as much as instructions are important, the data is also equally important in every application. And the way we are going to deal with data is going to be purely based on the type of data we are dealing with. See, I cannot say all the data is of same data type. We have integer, we have got strings, we have got double, we have got floats, we have got characters, we have got boolean, we have got chair, table. All these are different type of entities. I can't deal with chair the way I would probably deal with a table. Like that, I can't deal with the integer the way I would probably want to deal with double, or probably I want to deal with string or character. Every type of data has to be dealt in a different way in different kind of situation. So it is very important as a developer we really understand what is the type of data we are going to deal with and appropriately associate the data type with it. And as I show here, there are two basic reasons. One is based on the data type, the size of the variable and the format in memory is decided. See, take for example now, here I clearly mention short or let us say integer is 4 bytes, and then we have got a data type called as double, even that is of 4 bytes. That does not mean both 4 bytes and 4 bytes are represented in the same format in the memory. The way integer is represented in memory and the way float data type is represented in memory, it's completely different. They are not same. This everybody knows it. So yes, float and float and integer, even though are of same type, even though are of same size, they are given different formats in memory. So I would say based on the data type, not just the size of the variable, but also the format of the memory is going to be decided. That is one part. And the second important part is it is based on the data type only. The language compiler is going to decide whether the expression which we have written is valid or not valid. For example, I cannot divide a string by a numeric value. Compiler is going to detect that we are trying to divide a string variable by a numeric value and it will give an error. So yes, we can't do that. So there are two basic aspects you have to keep in mind at the time of declaring a variable, why we are giving data type to it. One, based on the data type, the size and the format of the memory is decided. Based on the data type, the language compiler is going to validate the expressions. I hope I make things very clear here. Going further, wherever we are taking data types into consideration, obviously data types are associated with the variables in the application, and variables are in memory. I say memory in the application is divided into majorly three parts. One is global memory area, the stack memory area, and the heap memory area. Now what is global memory area? Generally those variables which are allocated memory when the application begins, and those variables which are going to stay in memory permanently throughout the lifetime of the application. I would like to declare them as global variables and they would stay there in memory permanently. These variables are going to reside in global memory area of the application. The size of the global memory area, I would say, is decided at the compile time and it remains fixed throughout the lifetime of the application. There is no separate memory management required for variables which are in global memory area. And at the same time, we have got stack memory, which is going to be used by all the local variables of the method and of course the method parameters also. Whenever a method is called, whenever we are calling from one method another method, a stack of memory is given to that method. In that method, we have all the variables allocated memory. That means all the local variables of the called method and the parameters of the called method are allocated memory on the stack of that method. Now the reason why we are calling this as stack is it's like one method calling the other method, on that one more method, like that one more method. It's like one method calling other method is what the whole thing is happening in our application. So it's like a stack of memory created. I hope it's clear. So yes, whenever a method is called, a stack of memory is allocated to it. In the stack of memory, the local variables and the parameters of the method are allocated memory. And when the method returns, the stack is automatically cleared. These instructions for allocation of stack and deallocation of stack are automatically generated by the language compiler. A developer doesn't have to take care of it. The method called will have its own stack, and the method called when returns back to the calling method, the stack is automatically cleared. Yes, the most important part of any application is the heap memory. the heap memory is going to be used for all dynamic memory requirements of an application. For example, if at all you know C language, whenever we are giving some memory to the pointer using malloc, calloc, that is calloc, we are actually borrowing the memory from the heap and giving it to the pointer. The pointer uses that memory for its time period, for its duration, when it is being used by the programmer, and when we say free, the memory is returned back to the heap. In the sense, all dynamic memory requirements. Now what do I mean by dynamic here? Those memory requirements which we don't know until runtime how many bytes of memory I would need. I'm not sure, in many circumstances I'm going to deal with one integer or I'm going to deal with 10 integers. So in these kind of situations, or I'm going to deal with only one string or 100 strings. So until runtime, when we are not sure about how many items of one type we are going to deal with, we go for dynamic memory allocation. We go for memory allocation to those kind of variables from heap. So heap memory is used for fulfilling all dynamic memory requirements of an application. Important point is, a programmer when trying to use heap should be very smart enough to return the memory back to the heap once that variable which is being used, which is using that memory, has completed its task. Because the heap is not like unlimited. The heap is very limited in the application. The default heap size, to my knowledge, is 1 MB. So up to 1 MB of memory can be used by the variables in our application. But when our variables are just borrowing memory from the heap, and if they are not returning it back, a time would come when the heap is exhausted and the application would crash. And this is a very common problem in C language, which is generally referred as memory leakage. We borrow the memory from the heap, we give it to the pointers, but we don't return the memory back to the heap for whatsoever reason. But yes, we may not be able to write some code in some execution path where we don't say delete or free and the memory is not returned back to the heap. And like that, if the block of code where we are allocating the memory to the pointer is called repeatedly, over a period of time, the situation would occur where the whole heap is exhausted and the program would crash. So heap memory management is very important in any application programming if a developer is writing the code in C language or C++ language. In .NET, we don't really have to manage heap. We have got garbage collector which is going to do the heap management for us at runtime. Anyways, we'll keep the garbage collector issue for the time being aside, will not concentrate much. But yes, keep in mind, variables can go in global memory area, variables can be in stack memory area, variables can be taking memory or borrowing memory from heap. Every global variable will go in global memory area. Every local variable is always going to reside in stack memory area. I hope things are a little clear over here. Now, the reason why we are talking about all this is, in .NET, all data types are categorized as either value types or reference types. Straightforward classification. You take any data type, looking at the data type, you can say it is a value type or it is a reference type. Going back to the first page of our demo here, you see all these data types are value types except for few like string and object. Only these two are reference types, otherwise all are value type. Now what is the basic difference between reference type and value type? See this diagram. If a variable is considered to be of value type, where when a variable is allocated memory, it will itself hold the value. Whereas when the variable is a reference type variable will reside in memory and would have a reference to the value where the value is on heap memory. So what is the basic difference between a value type and a reference type? A value type has the value, a reference type holds a reference to the value. And the value of a reference type is always on heap, not on stack. Now here goes a confusion. When I ask many people what is the difference between value type and reference type, a common answer which I get is value type